Chat with Timmy. I am meteorologist Albertson, and tonight we're going to take a look at some of those snowfall totals that we had from that lake effect snow event on Monday and that carried over into parts of Tuesday. And then we'll talk a little bit about the forecast for parts of eastern Texas for the day tomorrow, as they could very well be seeing the possibility for maybe a couple of strong thunderstorms there. So, without any further ado, let's go ahead and we'll take a look at some of those snowfall totals that we had across parts of the Great Lakes. Now, for those of you who might not be familiar with lake effect snow, let's go ahead here really quickly and take a little bit of a look at the snowfall map here. So what you're looking at here is just that. It's a snowfall map over the past 72 hours. And normally when we talk about snowstorms, you would think that we would see kind of a broad area, more or less, of high snowfall totals. Well, that is the case if we were talking about a regular area of low pressure, producing snow showers. But lake effect snow showers are a little bit different. As a matter of fact, if you're not familiar with the Great Lakes, a lot of times, once you get those strong systems to push through, they might bring a little bit of snow, but it's what happens on the backside behind that cold front when most other places are clearing out and seeing, very kind of quiet weather. It's not necessarily the case sometimes on the Great Lakes, and a lot of that has to do with, the wind speed as well as the difference in the air temperature of the lake, or the water temperature of the lake, and the low level air temperatures there. So a lot of times in meteorology, we use about 13 degrees Celsius as kind of the good difference between the temperature of the water and then the temperature just a couple thousand feet above the ground. And that does kind of produce a little bit in the way of convection. Again, that warm air is going to try lifting into that much colder air. So let's talk about how that plays into role in lake effect. So all of a sudden we got this warm kind of moisture air over the lake, relatively speaking, and it's lifting into an environment where the air temperature is about 20 degrees colder. And this is only a couple, about 3,000 feet above the surface of the water. So you can imagine that's a pretty good temperature gradient. So what ends up happening is that produces convection, and eventually that leads to snow showers. And then the winds will push it inland a little bit. This is called lake effect snow, and it does take a couple different forms in exactly how it looks. But what's very unique about lake effect snow is just how localized it can generally be to a specific area. So let's take a look at the snowfall map here, and I'll kind of walk you through exactly what you're looking at. So, for those of you who know, I probably mentioned it numerous times before. Growing up, I was in Erie, Pennsylvania, quite a bit, multiple times a year, and then even when I went to university, I spent the first 2 years over in Erie. So, very familiar with it. And one of the things I loved, even growing up, about this part, going from Pennsylvania. Say, I grew up in Northwest Ohio. Okay, we don't get lake effect snow there. Very rare if we did. But what I always thought was very fun to do at this time of the year is you drive I-90 or 80-90, depending upon what part of Ohio you're in. But it's going around Cleveland. All right, this is the Cleveland Metro. So let's go ahead here and just kind of take a look. We won't zoom in, but we can kind of get a good idea here. So I-90 would course its way right through here in Lorain County and then cross over into Cuyahoga County. And as long as you stay on 90, you go into downtown Cleveland around Dead Man's Turn. And then you basically kind of ride almost parallel here with the lake as you make your way through Lake County. And then eventually you kind of back off a little bit and go into some slightly higher elevation across parts of Ashtabula County. So look at this map, and you can imagine that this only takes about an hour to an hour and a half, depending upon traffic, to drive from one end of the Cleveland Metro to the other. And again, part of the reason for that length is just because the speed limit drops down a little bit in Cuyahoga County. But look at this snowfall map here, okay? So in one part here of the west side of the metro, there's a dusting, if even that, of snow. Go to Cleveland, they got a little bit of snow there, about an inch or so. And then take a look at this. As you head over to Lake County, look at that. Already seeing snowfall totals of about 6 to 8 inches. That's a pretty big difference, even in one metro. And again, Cleveland's not like Chicago Metro, which, is a little bit larger in area. Cleveland Metro is, well, confined to generally this little area right. So you can imagine how in that short amount of time, in that short amount of distance, especially once you cross downtown Cleveland going into the east suburbs of Mentor, Euclid area, Mentor being kind of the main one over on the east side. Look at that. Completely different than Lorain and Elyria on the western side. That's lake effect snow. Now, We're going to come back to this little part right here, why it's a little bit lower right there. But let's kind of take a look here, though. And you can see how those snowfall totals actually increase a little bit more as you head over into Chautauqua and Cattaraugus County in New York, and then parts of Erie County. I know there's a lot of Erie counties right next to each other. There's Erie County, Ohio, Erie County, Pennsylvania, and then Erie County, New York. It does get a little confusing sometimes when you're dealing with different weather offices. And actually, it's really fun because Cleveland office has both Erie County, Pennsylvania, and Ohio, so that's fun sometimes. But anyways, moving rapidly along here. When we took a look at the radar on Monday night, we observed one kind of singular snow band. It was a pretty strong one. Again, those winds were coming out of the southwest a little bit over Lake Erie. That's important because that air, that colder air, is traveling a longer distance over the lake. So it's picking up a lot more moisture. And it just so happened to kind of drop itself right in this area. For those of you who've grown up around Lake Erie or are familiar with it, this is the area that gets the lake effect snow, climatologically speaking, in every other scenario for the most part. Once you get to the northeast of Erie and then heading into the south suburbs of Buffalo, not actually the city itself, and that's where it gets really fun. Take a look. Buffalo picked up maybe about an inch or two of snowfall. We'll take a look at maybe some of the more exact numbers here in a little bit, but look at that. Look at how sharp of a contrast that is. You go to the southern part of the county, and that's how it generally shapes out to be, quite honestly, with some of these bigger lake effect snow events, is that's actually usually how it works out, is that the city itself of Buffalo doesn't really see much. But once you go a couple miles to the south, boom, you got 2 feet of snow sitting there. And in this case, it's about what? 12 to 18 inches of snow in that part of the county. So again, very localized. And if you've never been in lake effect snow, I highly encourage it. To me, it's one of the most fascinating things. You can be driving, and depending upon the setup and again, every lake, it depends on the wind direction. And again, not every lake is the same shape. So you get different kind of effects here. So what we're taking a look at right now is kind of that singular band that's set up at least somewhat across this, that traveled its way all the way across Lake Erie and then dumped itself pretty much right over New York and then kind of drifted a bit to the south. And then there were some other things that kind of played that played a role. But I mean, folks, that's really, really sharp. Now, what you probably don't notice here on this map is if you've never been around this area, this is a very higher elevation area, but it drops down steeply towards the lake. This is actually very important for a couple of reasons. Number one, when you have kind of higher elevation right up on a lakefront like that, or you have this lake effect precipitation coming up, it gets forced upwards. Because again, remember the elevation as you go away from Lake Erie increases in this case, especially, and it does so very dramatically on the east side of Lake Erie. The west side of Lake Erie, northwest Ohio, sat under a glacier and for the longest time, and then when that receded it was actually a swamp. Well, actually it was a glacial lake called Lake Maumee, and then that turned into Lake Erie. But anyway, so the elevation change on the west side is not very extreme at all, but it is certainly on the east side here, especially right up here on the Appalachian Plateau. Now basically this plays a very important role because the lake, especially early in winter, Lake Erie now we're talking about. Now, like I said, every lake is different with this, but they all kind of follow the same pattern, but because their shapes are different and their depths are different, it does play a little bit of a role. But for Lake Erie's sense, we'll talk about this, and yes, we're going to take a look at some of the other lakes here, but Lake Erie again, is the shallower of the lake, but this is actually the deeper part. All right. It's very, very shallow over here in the central, and once you go over towards the Toledo area. In fact, sometimes on cold winters, that will freeze over pretty early on. But this tends to stay open at least a lot longer. And again, it doesn't freeze over every winter, but if a particularly cold winter, it will freeze over, especially once you get into the bay. But until that time, this is, temperatures in the 30s. So when you have an air mass that's bringing temperatures, in the teens, okay, over that, there's your temperature contrast. Now, Lake Erie is a little bit warmer than 30 degrees and then, 35 degrees, but you get the idea. that's what produces that lake. That's that instability. You got that colder air just above the lake, and it's rushing quickly over that warmer air. And again, it's just picking up that moisture and it condenses. So what happens though is there is a little bit of a ridge right here. And if we were, and that's what I should have, I should have put up the elevation map, but you get the idea. The elevation increases the further away from Erie that you do go, and I-90 actually sits right on the top of that ridge, which is actually kind of funny. But long story short, this area down here will stay a bit warmer during the early winter because the lake is still influencing its temperatures. Until it freezes over, this area right here in particular is kind of at the mercy of whatever the lake temperature is. So that's why you see a little bit of a decrease here. And part of the reason for that is that the temperatures were probably it was probably snowing there, but the temperatures were just a little too warm for it to really accumulate. And sometimes you can see it very dramatically, in early sometimes in the month of November, where it'll actually be raining in Erie, but you go a few miles up the ridge and it's full on white out there. So that's why you see the lake effect totals are a little bit lower here. Part of that has to do with the fact that the lake temperature is still influencing that, whereas up here it was sitting in the 20s during that event there. So there was not really much of a problem with snowfall accumulation. Now, folks, snow can accumulate if the temperature is above 32 degrees. It's just a little bit more difficult, as it has to overcome the melting in order for that to work. So, all things considered, though, very localized snowfall totals here. Now, the elevation increases here, and what that does is that brings that, it allows that precipitation to kind of exhaust itself. It gets forced upwards by the geography, and that causes it to kind of produce a little bit more. And this goes into, I don't want to say mountain meteorology, but when you get into orthographic meteorology, this is actually a very big player, especially on the West Coast. But that moisture gets drained out a lot quicker, and you can see how it just kind of drops off. All right, St. Mary's didn't really see much. Olean did see some snow, but once you get further off towards the to the east there, they didn't really see quite as much. Now, depending upon the topography, sometimes we can see these lake effect snow bands and some other conditions really extend. In fact, I remember one winter tracking one that was up off of Lake Ontario. It was January, and that thing was long, but it was narrow. It was very narrow. It was only like about 12 miles wide or something like that, but it stretched over 100 miles. So again, sometimes then you get moisture connections, and that's really fun when you get a connection from one lake over to the next, and that does happen sometimes, and those are also very fascinating. So that's Lake Erie. Again, they get their best lake effect snow if the winds are coming out of the southwest. Typically, you see that with a stronger low pressure system, when it includes its way through. Now, if the wind is coming out of the northwest, yes, it will produce lake effect snow, but it does not, but the air does not spend as much time over the water if it comes in from the northwest. So that tends to produce a little bit more of not necessarily one snow band, but a bunch of kind of moderate snow bands here and there. And wind shear also plays a little bit of a role in that, but we won't go into that tonight. So northwest winds will bring lake effect snow pretty much to this entire area too, but normally not to the scale that you see with a singular band. Now the singular bands tend to affect southeastern New York. Southwestern New York way more than they do this part of Lake Erie. There are exceptions. There are very big exceptions. I remember a couple of years ago, one of those strong lake effect snow bands set up, and then it drifted down to the south a little bit, and it pummeled Erie, Pennsylvania, with about 6, 7 feet of snow in about 36 hours. That's a little unusual for the city of Erie itself. Yes, they do get lake effect snow, and they have gotten some big numbers, but that one was a little unusual because typically we don't see those snowfall bands setting up right over Erie. Normally they're just a little bit further up towards the north. So you get the idea, though. But that was the same kind of setup, though, that produced that 7 feet of snow in Buffalo about a year or two, 2 years prior to that one in Erie. So again, this is all right. All right. I think I've hammered home the point enough. Let's go ahead here and see if we can't move up a little bit to our good friends over in Lake Ontario. Here, let me go ahead and try to nudge this map up here just a little bit and take a look here. This is Lake Ontario. Now, Lake Ontario does not normally freeze over. It's a lot deeper than Lake Erie, but look at that. Singular snowband. Wind was coming out of the west. Look at that. That's some very high snowfall totals. It'll be interesting to take a look at some of those numbers. Watertown is a city that really gets pummeled. Uh, quite often throughout the winter. Again, Lake Ontario is way deeper, so it doesn't really freeze over. Let's go ahead, folks, and take a little bit of a look into Michigan here. They did get some lake effect snow, but here's what's very unique about Michigan's. And basically, we'll just kind of take a look. I guess I know there's some snowfall up here, but we're going to focus on the lower, on the mitten here, the lower peninsula first. Let's take a look at this snowfall map here. So, Michigan gets lake effect snow too on the western edge, but it's normally not as much as what you would see in southern Buffalo or Erie, Pennsylvania, or Watertown, New York. And part of the reason for that is I know I'm blocking it here a little bit, but this is Lake Michigan. The air does not have enough time to travel over Lake Michigan as it would if it was going longwise up Lake Erie. So typically, when we see lake effect snow uh, impacting the lower peninsula of Michigan, we tend to see it not quite as intense if the winds are straight out of the west. So places like Grand Rapids, Kalamazoo, yes, they get lake effect snow, but normally not to the quantities that they will get, in other places. And part of that's just because of the length of time. Now, again, you can get enough weather fronts to push through, and easily you can get some other city that would top the list every year. And yes, these cities do keep track of who has the most snow. It's an actual thing. And Syracuse. Syracuse is kind of like the Ohio State of lake effect snow champion cities, but whatever. Um, or Alabama. I'm a Penn Stater. That's not the point. The point is that you can see here they had lake effect snow, but it was not quite of the high values. Now, what happened up around Traverse City? Well, by that point, when the lake effect snow event was happening, it was a little bit more of a northwesterly wind, and it did get some assistance. If we zoom it up here, I'm going to go ahead and move it to about here, and we'll get the other peninsula here. So you can see that the winds coming out of the northwest, a little bit of a moisture connection with the lake effect snow that was coming off of Lake Superior, kind of continued on over here. So that's why these numbers are a little bit higher up here. And again, that kind of generally tends to be the case. Obviously, Upper Peninsula of Michigan does get lake effect snow too, and they will get theirs all winter long because Lake Superior does not freeze. It is very deep. It's basically a freshwater sea. So it does not really freeze, and places like Marquette will get pounded quite a bit. For Lake Superior, it is kind of interesting, is unlike Lake Erie, where if you get a northeast wind, it's probably not going to produce much lake effect snow. Maybe some lake effect flurries. I can only recall about once that it ever happened in Toledo, and the whole time I was growing up there. But it's a very interesting in Lake Superior. The little triangle tip here. Oh, I'm blocking it. You can't see where I'm pointing. Let me go ahead here, and we're going to move this over really quickly, and then we're going to go ahead and take a look at some weather stuff. So let's go ahead and flip on over here towards Lake Superior. And this part right here, if the winds are out of the northeast, will produce lake effect snow. Typically, it's, by the time that, happens, it'll be cold enough that it will be produce snow. But we don't see that on the parts of on Lake Erie on the far eastern edge. And again, just typically because it's not as cold. Or when it does happen, the lake's already frozen, at least in that part. So, again, the thing about lake effect snow, folks, to keep in mind here, and we'll go ahead here and see if we can't zoom out just a little bit here, because this will give us a very good idea. As when you take a look at lake effect snow, you can see how it's almost always the predominant wind direction. It is the predominant wind direction, which in most cases is westerly or some form of that westerly wind. So places like Toledo don't really ever see lake effect snow. Places like Green Bay don't really see lake effect snow. Even though they're right up on the lake, they don't see it. Actually, Toledo is technically a couple miles in from the lake. It actually is on is actually on the Maumee River, but whatever. You get what I'm saying, though. And that is that, places like Detroit, right up on the lake, but they don't really see lake effect snow because of the prevailing wind direction and some other things. They'll get lake effect flurries, as I like to call. So just because you're close to a Great Lake doesn't mean you're going to get it. You have to be downwind from it to really get it. And most of the time, that wind is west or northwest or some variant of that. Chicago is a very interesting one when it comes to lake effect snow, because if the winds come straight out of the north, and it's cold enough, it will actually produce some decent lake effect snowfall between Michigan City heading over to Gary and the Hammond area, and even maybe a Calumet City over in Illinois. But that's not very common. Uh, but it can happen, and it does happen. I've seen it before, and typically it can produce some pretty decent snowfall totals, at least on the order of a half a foot if it does happen. But typically, the winds end up being a bit more northwesterly, so it goes to places like South Bend or Plymouth, heading up to Niles, Michigan, and that area there. But again, if the winds are straight out of the north, it can happen. It can and has happened before. Uh, it'd be interesting to look at the number. I'd say maybe about once a year, maybe once or twice a year, does that happen, but it does vary in intensity. But yeah, Kenosha, Racine, Milwaukee, they don't really see lake effect snow. So that's that. All right, let's go ahead here and folks and take a look over at the radar. Now we're going to talk about we're going to obviously talk about it way more during the day tomorrow, but I just want to give you guys a little bit of a heads up. We are expecting the possibility for some strong parts of East Texas and Louisiana as we head into the day tomorrow. Now, the Deep South trail season is kind of an all-year thing, but really it's wintertime and spring that we do see it at its height. Now, right now, things are very quiet there. There is a possibility there could be some storms developing overnight in that area, and we'll see if those carry over into the morning because that could play a little bit of a role. But let's go ahead and take a look at the latest weather map really quickly here, and we'll kind of get an idea of what's going on. So, we got this area of high pressure right now centered right over the deep south, kind of bringing in a nice southerly wind across parts of Texas and into Oklahoma. We have this area of low pressure back out here. A little hard to see, but it is there, but it's not moving right now. It's actually going to have to wait. We're going to be watching as an upper level little shortwave trough here pushes its way out of the Four Corners area tomorrow, and that is going to help to trigger that low pressure to begin to move. And for simplicity, for simplicity's sake here, we'll go ahead and just take a look over at the WPC's forecast map here, so we kind of get a little quick idea here of what exactly it's going to look like to a degree, or good estimation here. Of course, obviously, as I mentioned before, we here at AWSC have our own forecast stuff that we do. Uh, but again, for the purposes of these weather chats, it's really quick and easy for me to show this map here. So again, as we go into tomorrow, there's that area of low pressure making its way to the Oklahoma-Texas panhandle overnight tonight. And then as we head into the day tomorrow, that upper level shortwave begins to kind of push that low pressure out, and take a look there. It begins to intensify pretty nicely as it crosses into Oklahoma. Now, it does begin to occlude, which again typically means that center of low pressure will be weakening, but a lot of times we see new centers of low pressure developing with it. But if you look down right here, we have that warm front there. We got that warm moist air coming off the Gulf, and we have a cold front that's going to quickly approach. And that could allow for a window where we could see a little bit of an unstable atmosphere. And with enough wind shear that we could be seeing some possible strong storms down across that area as we go into tomorrow afternoon and then heading our way into tomorrow evening. That front then pushes its way further to the east, and that'll likely begin to taper that event off just a little bit, though there could maybe still be a few strong storms hanging on. So if conditions are right, we could see maybe some of those storms trying to rotate. Now, when we talk about supercells do rotate. They just don't always produce tornadoes. Case in point, like when we were watching those storms in Mississippi last week, they did produce a few little touchdowns here and there, but for the most part, those storms, while they looked very nice on the radar, just did not have enough low-level rotation. So it'll be interesting to see how tomorrow's plays out. Again, we won't go into the specifics of it tonight, but we will be watching it tomorrow, and of course, we'll do some Facebook video, or not some Facebook, we'll do some of these videos for it when it does happen, if it does happen. And regardless, we'll have our weather chat tomorrow night, and we'll talk all about that. So it'll be pretty interesting there. Winter is a fun time of the year. Again, especially when you get these strong lows, you get blizzards on one side and severe weather outbreaks on the other side, and it never fails to be interesting. And then if conditions are right, you get a good lake effect snow system behind it. And then actually that plays into it, can sometimes help to produce a nor'easter across parts of the East Coast. So wintertime, these things tend to be, these systems tend to be a lot stronger. Part of the reason for that is the temperature contrast. Again, you're dealing with colder air, but places down in like the deep south don't really cool down that much. It's still pretty warm down there. And when you're dealing with that cold Canadian air that comes out of the Arctic, well, again, it gets kind of a fun little time there with a pretty good temperature contrast. So that's why you get so many strong lows during the winter time. Alrighty, everyone. Well, I think I bored you all enough for tonight. So, with that in mind, we'll go ahead and wrap this video up. I thank you all very much for taking the time to join me here on this weather chat. And if you haven't already, I know I'm going to sound like the cliche YouTuber, but make sure you like and subscribe to our page. I don't have that little click button thing though. I'm not going that far. But anyways, so with that in mind, everyone, I hope you all have a good rest of your evening and keep enjoying that weather. And we'll see you back here tomorrow evening for the next weather chat. Take care, everyone.